Today I'm going to talk about some definitions related to linear equations in one variable. Linear equations in one variable are written in this form, where a, b, and c are real numbers and a is not equal to 0. Now each piece of this equation is called a term. So this is a term, this is a term, this is a term. This first term, the ax, is called a variable term because that's the term that has the x in it. B and c are called constants or constant terms because they don't have a variable in them. The number in front of the variable, the coefficient, it's called a coefficient, the number in front of the x. So when we have a variable term, there's going to be a coefficient times the variable. Now, why is it important that a is not equal to 0? Well, what if a was equal to 0? What would happen? Well, 0 times x is 0, and then we don't have a variable anymore, right? And this needs to be a linear equation in one variable. So I need a variable. So here's some examples of linear equations in one variable. This one I put in a few numbers, right? This one might not look like it works originally, but I can use the distributive property and rewrite it like this. I can also put in fractions for a, b, or c, or negative numbers for a, b, or c. These are all examples of linear equations in one variable. So what are some things that are not linear equations in one variable? Well, this is an example. This is linear, but there are two variables, so this does not count. You have something where x is squared. This is not linear. If x is an absolute value, again, not linear. If x is in the denominator, not linear. So I've graphed these equations. There's the first one. Again, it is still a line. The problem is we have two variables. If we have an x squared somehow in our equation, right, that's a parabola, which is a U-shape, either U-shape up or an upside down U. If x is an absolute value, it's going to be a V shape or an upside down V. And if x is in the denominator, we have something called a rational function. We haven't talked about these a lot yet, but the graph looks, for this equation, the graph looks like this, right? X cannot be equal to 0 because we can't divide by 0. So this really weird thing happens where this doesn't ever quite get to 0. And this line up here doesn't ever quite get to 0. So we get these really weird looking functions that are not linear. A solution to an equation is a number that when we put it in for that variable, we still get a true equation. So that's how we check to see if our solution works. We need to make sure that the equation is still true. So, is 3 a solution of 2x plus 3 equals 11? Well, first step is to substitute 3 for x and then simplify. 2 times 3 is 6, plus 3 is 9, not equal to 11. So 3 is not a solution for that equation. Is 4 a solution? Well, again, first step, substitute 4 for x. I get 2 times 4 is 8, plus 3 is 11. I get 11 equals 11. That is true. 4 is a solution to that equation. Okay, I am